used integrals to do lots of things. We can do integrals to find the area under a curve is the big one. We can use them for antiderivatives, all sorts of good stuff. We use them for volume. Now we're going to use them for arc length. Okay, so when you were back in 7th or 8th grade, you learned something called the distance formula, and the distance formula allows you to find the distance along a straight line. This is the way you find the distance along a curved line. Now, when you saw arc length, you may be thinking back to something you did in geometry, where you found like the portion of a circle. So like, let me just show you. Back in geometry, you may have been given a circle, and then they divided it something like this and said, okay, find this arc length from here to here. Now that is arc length, but that's not quite what we're talking about in this lesson. We're talking about something more like, let's take y equals x cubed, which would look something like this, and then find the length of it from here to here. Okay, so you can see that's not a straight line, so it's not something we could use the distance formula to find. So we use this formula instead, that s equals the integral from a to b of the square root of 1 plus f prime of x squared dx. Okay, so we're just going to dive right into examples for this. Actually, let me say this first. So this formula gives the arc length of f of x. Notice we'll be plugging in f prime of x, but it gives the arc length for the original function from a to b. So for this first example, it says find the arc length of the graph of y equals 1/6 x cubed plus 1/2 x to the negative 1 on the interval 1/2 to 2. So we'll set this up. We do the integral from 1/2 to 2. Those boundaries were given to us. Then we do the square root of 1 plus. Now we need to take the derivative of our function. Okay, the derivative of 1/6 x cubed is 1/2 x squared. The derivative of 1/2 x to the negative 1 is negative 1/2 x to the negative 2. And then we square that and put a dx on the end. So to be clear again, you take the derivative of your equation, then you have to square it, and then take the square root of the whole thing and do the integral. So we can do this in our calculators. We use Math 9. Make sure you do a square root immediately. And you do 1 plus parentheses 1/2 x squared minus 1/2 x to the negative 2. And you close those parentheses and you square that, because we have to square the derivative. Then do comma x, comma 1/2, comma 2. Okay, I made an error. Let's see what it was. Okay. If you look back up here, I started a parenthesis right after the square root, and I never ended that. So I need to end that after the squared, and then that should fix that. Let's see. There it is, 2.0625. 2.0625. So do make sure you close your parenthesis for the squaring of f prime and also the square root of the whole thing. So this equals 2.0625. Next example, it says find the arc length of y equals the natural log of cosine x from 0 to pi over 4. So I set this up, the integral from 0 to pi over 4 of the square root of 1 plus. Okay, now when I write this, I have to remember the rule for natural log, because I got to take the derivative. It's the derivative of the inside over the inside. Well, the derivative of cosine is negative sine, and then over the original is cosine, and then we square that. Okay, I'm going to rewrite this. You don't have to do the simplifying. You could plug it in just as is. But if you remember, sine over cosine is equal to tangent. And really, you don't even need to put the negative there, because once you square it, that'll change it back positive. So let's plug this one in. We'll get Math 9 of the square root of 1 plus parentheses tangent of x squared, close the parentheses for the square root, comma x, comma 0, comma pi over 4. Alright, I think I need to check my mode. I think this is not quite right. Yes, make sure your calculator is in radian mode. Plug that in again, and this time get the right answer, 0.881. Alright, so I plugged it in correctly, I was just in the wrong mode. So make sure you're in radian mode always in calculus class. One last example. It says find the arc length of y minus 1 cubed equals x squared on the interval from 0 to 8. The reason I'm doing this one is I want to show you that you can actually do these with respect to x or with respect to y. In this case, I think it's easier to just solve for x, so we will do it that way. So we'll take x equals the square root of y minus 1 cubed, or another way to write that would be y minus 1 to the 3 halves. Because square root is the same as 1 half. Okay, now technically when I take the square root, I have to do plus or minus. The reason I chose to make it positive is because if you look at the interval, it's 0 to 8. So it's positive x values I'm dealing with. So that's why I made it the positive square root. Okay, so when I set this up, I do s equals the integral of the square root of 1 plus, now I have to take the derivative of this. So it's going to be 3 halves times y minus 1 to the 1 half. And then technically we do the derivative of the inside, but that's just 1, so we don't have to do anything extra there. Then we square that and put dx. Okay, if you notice, I haven't written my boundaries yet. And actually, excuse me, this should be dy, because we're doing it in terms of y. And that gets to the point of the boundaries. I haven't written them yet, because I actually don't have them yet. The boundaries I was given, 0 and 8, are x values. If you're going to do things in terms of y, you have to change your boundaries to be y values also. So you can solve for those. Just plug 0 in for x and plug 8 in for x. So first, if we plug 0 in for x, we get y minus 1 cubed equals 0. So cube root both sides, and we get y equals 1. So that's our boundary for the bottom. When x is 0, y is 1. And then we also need to do the same thing with 8. So 8 squared is 64. We take the cube root of both sides, and we get y minus 1 equals 4. So y equals 5. So our boundaries are from 1 to 5. Okay, this is the last example. Let's see if I can do this one flawlessly. Math 9, square root of 1 plus parentheses 3 halves times parentheses x minus 1 to the 1 half, close parentheses and square that, then close my square root parentheses, do comma x, comma 1, comma 5. And let's hope. Alright, that's it. 9.073 is your final answer. So again, this is the way to use an integral to find arc length, or the distance on a curved line or a curved function from one point to another.